Hello, everyone, and welcome to the final speedrun of today with me, Vince. So today we're going to be going through a bit more modifications to the synthetic division that we've been learning, and we're going to be learning a new theorem. So, actually, it's not a new theorem, it's a modification to a theorem that you already know. And so we already know that given a polynomial f of x, if if we divide this by an expression x minus p, then we expect to get the result of f of p. But what we now need to build on is what if this x has a coefficient? What if it's not just x? What if it's like 2x or 3x or something? And so what we actually can figure out is that f of x of ax minus b, where a and b are of course real numbers, is equal to f of b over a. And so this makes things a bit more interesting. So in order to use synthetic division, we need to modify our algorithm a bit. So we know that, of course, f of x is equal to g of x times q of x plus r of x. But we actually need to transform this since we know, of course, g of x equals ax plus b, minus b. Well, that times the quotient is, plus r of x, because you can sub in our linear expression over there. And so, where is it? So we have f of x. Well, let's take this a out of the brackets. So we'll set it to a over x minus b over a times q of x plus r of x. So, yeah. So now we can group this into f of x is equal to x minus b over a times a times q of x plus r of x. So yeah. So with this modification, we can now substitute negative b over a into the algorithm instead of just negative p to get the quotient and the remainder. So let's jump into some questions so we can solve a few. I'll do the odd ones again. So first of all, we have the expression 4x cubed minus 5x squared plus 13x minus 2, and we need to divide this by 4x minus 1. So that's okay. Let's set up our synthetic division. We have 4, negative 5, 13, and negative 2, and we need to divide it by negative b over a. So negative 1 over 4 is equal to 1/4, so we should be dividing it by 1/4. Right? Yeah. So let's do this. So first of all, we drop 4 down. 4 times 1/4 is 1. So we have 1 over here. 1 plus negative 5, negative 4. Negative 4 times 1/4, negative 1. 13 plus 1, 12. 12 times 1/4, 3. Negative 2 plus 3, 1. So our final polynomial is 4x squared minus 4x plus 12 with a remainder of 1. So plus 1 over, what is this? Where are we? 4x minus 1. So that would be our answer. So, oh wait, hold up, I haven't explained something. So, one slight modification we need to make is, remember, this is outputting, let's go back up. Oh, I've erased it. So this output is actually being multiplied by a, because if we saw earlier, let's go back to the earlier formula, we have x, f of x is equal to x minus b over a times a of x times a times q of x. So to get the real quotient, we also have to divide all of the terms with an x in them by a. So actually no, just all of the terms but the remainder by a. So we have to divide all of that by 4, so we get x squared minus x plus 3 plus, and we leave this unchanged because we know that the remainder, let me just add it right there, is not being multiplied by a. So we can leave that untouched. So we have x squared minus x plus 3 plus 1 over 4x minus 1. So that's the answer. Oh, not the ruler. So let's move on to the next question. And that one asks for 2x to the 4 plus 3x cubed minus 6x plus 4x, 6x squared plus 4x plus 3. And we need to divide this by 2x minus 1. Okay, so let's synthetic division it. We have 2, 3, negative 6, 4, and 3. And we need to divide it by effectively 1/2, since this would be negative b, negative 1, negative 1 over 2, which is 1/2. So drop down 2, 2 times 1/2, 1, 3 plus 1, 4, 4 times 1/2, 2, negative 6 plus 2, 4, 4 times 1/2, 2, 4 plus 2, 6, 6 times 1/2, 3, 3 plus 3, 6. So, oh sorry, this should be negative 4. I made a mistake, negative 4, therefore negative 2, 4 minus 2 is actually 2, oopsies. And then 2 times 1/2 is 1, so we have 3 plus 1 is 4. So, well, we're left with 2x cubed plus 4x squared minus 4x plus 2. Well, we have to divide this by 2, remember, because a is 2. And then we have plus 4 over 2, plus 4 over 2x minus 1. So this would be what? X cubed plus 2x squared minus 2x plus 2 plus 4 over 2x minus 1. So that should be correct. Plus 1. And the remainder is 4. I'm looking at the textbook actually, and the textbook's saying that this value over here should be 1, but I don't know. I think they've made an error since I don't see how this is wrong. Yeah. Anyways, on to the next question. So, we know that there's a function 6x5 plus 17x to the 4 minus 20x to the 3 minus 35x squared. Oh. Is this the... Oh, that was the largest. Let me clear this again. So we have 6x to the 5 minus 17x to the 4 minus 20x to the 3, sorry, plus 17x to the 4 minus 20x to the 3 minus 35x squared plus 44x plus a is divisible by 2x plus 1. Find a. Okay, so this should be pretty simple. Let's just synthetic division this number, and we should have a remainder of 0. So 6, 17, negative 20, negative 35, 44, and a. Okay, so, and we need to divide it by 2x plus 1, which is effectively dividing it by negative 1/2. So, 6 times negative 1/2 is negative 3. 17 minus 3, 14. Negative 20 plus 7 is 27. 27, so this would be what? Negative 35 plus 27 over, minus 27 over 2. Am I making a mistake? I don't think so. So, this would be negative 70, negative 97 over 2. This would be 97 over 4 plus 44 which is equal to 97 over 4 plus 34 is equal to 68 and 1/4. And so dividing 68 and 1/4 by 2, we should get -9 minus 34, 1, oh sorry, a minus 34 and 1/8. So a must be equal to 34 and 1/8, or 34.125, I think. It's a bit odd to give us a decimal though. I think I might have made a mistake. Let's check through again. So we have 6x to the 5 plus 17x4, 6 times -1/2. Oh, ignore that. I've just read this question wrong. So we were supposed to be dividing by x plus 2, not 2x plus 1. My bad. So what we actually have here is a case where we have -2 there, and we need to rewrite all of these numbers. So just erase all of that. So we have 6, that's fine. 6 times -2, -12. 17 minus 12 is 5. 5 times -2 is -20. Sorry, -10. -20 minus 10 is -30. -30 times -2, 60. 60 minus 35 is 25. 25 times -2 is -50. -44 minus 50 is -6. -2 times 6 is 12. So a must have been equal to -12. Yeah. So on to the next problem. Yep, sorry. On to the next problem. So the next problem is we have f of x is equal to x to the 4 plus 5x cubed plus 5x squared plus ax plus b, and it's divisible by x minus 1 and by x plus 2. Actually, I just thought of a better way to do this entire thing, other than merely dividing it. And it's, if you remember, if these two factors are divisible, then if we input 1 and -2 into this, they should output 0. So what do we know from that? Well, we know that 1 plus 5 plus 5 plus a plus b is equal to 0. And we also know that -2 to the 4 is 16, minus 5 times 8, 40, plus 5 times 4, 20, minus 2a plus b should also be equal to 0. So, well, what we can clearly tell is that from this up here, actually I'll take the bottom one first, b is equal to 2a plus -20 for 2a plus 4. So if we substitute that up here, we have a plus 2a plus 4 is equal to 11. So 3a is equal to 7. Is this right? Yeah, should be right. But it's interesting that a is equal to 7/3. I think I might have made a mistake somewhere. Let's go through it again. X plus 4 plus 5x cubed plus 5x squared plus ax plus b. I don't see any problems. We added up something wrong. It should be 11. Oh, it should be minus 11. Sorry. And so we have 3a is equal to minus 15. And so a is equal to -5. Since b is equal to 2a plus 4, that's equal to -6. So a equals -5 and b equals -6. Yeah, pretty easy. So next, on to the next question. Sorry, I'm back now. And so let's continue on to the next question. which is question 7. So question 7 says if we have a polynomial that we don't know exactly what it is, but when we divide it by x plus 2, we get a remainder of 4. And when we divide it by x minus 5, we get a remainder of negative 3. And so we need to find the remainder when we divide it by x squared minus 3x minus 10. Okay, so what does this tell us up here? This is pretty important, and this tells us that f of negative 2, since we have the function divided by x plus 2, it tells us that f of negative 2 is equal to 4, right? And it also tells us that f of 5 is equal to negative 3, since we're dividing by linear functions here. So the remainder should be the same when we substitute in the negative value. But what is this also equal to? F of 2, negative 2, is also equal to g of x, which in this case is, we can substitute x squared minus 3x minus 10, x squared minus 3x minus 10, times the quotient, whatever that quotient happens to be, plus the remainder. And since this function here is of order 2, we know the remainder must be linear, since anything above the linear will be eliminated by division. Similarly, over here we can say that's equal to x squared minus 3x minus 10 times, actually, well, what's x here? We're using x equals negative 2 in this upper one, so we can actually just substitute q of negative 2 into here, and then we can say minus 2a plus b, because x should be negative 2. And similarly in the bottom, well, we said that x would be 5, so we can actually substitute 5 into here, times the quotient of 5, plus 5a plus b. And that should be equal to negative 3. And now the thing is, if we substitute 5 into here, and also if we substitute negative 2, since these two are the roots of this equation, it means that this should be equal to 0. So actually, we don't have this at all, since it's equal to 0. So all we have left is, here we have negative 2a plus b, and here we have 5a plus b. And these are two linear equations which we can obviously solve. So we know that b equals 2a plus 4, so we can say negative 3 is equal to 5a plus brackets 2a plus 4. And so we have negative 3 is equal to 7a plus 4, so a equals negative 1. And then what's b? Well, b is equal to 2a plus 4, so that's negative 1 times 2 plus 4, which is equal to 2. So our remainder from the final division should be negative x plus 2. Since this is the coefficient of x, this is the coefficient of the constant in the equation. Is that correct? Yeah, that's correct. So that is the answer. And so we have the final question now. And so the final question is asking us to show that for polynomial f of x is equal to x plus 2 to the 2n plus x plus 3 to the n minus 1 is divisible by x squared plus 5x plus 6 for all n is an integer. N is a positive integer. Okay, well, we know that x squared plus 5x plus 6 is equal to x plus 2 times x plus 3. So if this is divisible by both x plus 2 and x plus 3, then it will be divisible by x squared plus 5x plus 6. So how do we test for divisibility? Well, we know that if we take the negative value of this, because this is p, if we substitute negative 2 and negative 3 into this equation, the result should always be 0, which means that they're factors. So let's try it for negative 2. We have negative 2 plus 2 to the 2n, which is 0, so we can ignore that. And so we are left with negative 2 plus 3 to the n minus 1. Well, what's negative 2 plus 3? It's 1. And 1 to the power of any number, n, is always 1. And 1 minus 1 will therefore equal 0. How about negative 3 then? Well, we need to consider negative 3 plus 2 to the 2n, and then this would be minus 3 plus 3, which is 0, so we ignore that term, minus 1. So this would be inside equal to negative 1, and since it's always to the power of 2 to the n, so we're sure it's an even number, the result of this would always be 1, and 1 minus 1 is equal to 0. Therefore, since it's divisible by x plus 2 and it's divisible by x plus 3, it should always be divisible by x squared plus 5x plus 6. So yeah, that was it. I hope you enjoyed the speedrun, and I hope to see you in the next one. Bye-bye.